Okay. Hello SOS. My name is Nico Contino and I'm a math tutor here in Montreal as well as a graduate student at Concordia University. Before I start, I would like to thank you for having me today. I decided to do Math 203, which is Cal 1, and talk to you guys today about the derivative. The derivative is extremely important. And then from the derivative, the limit definition of a derivative, we're going to move on to finding the equation of a tangent line at a point. So that's my goal for today. So let's begin with the derivative. I already wrote down the definition of a derivative. It's essentially the limit as h approaches 0 of f of x plus h minus f of x, all that divided by h. Okay? So the intuition, what I want you guys to have when approaching a derivative problem is this. Let's say we have a graph. This is the y-axis, this is the x-axis, and we have, let's say, a parabola. Okay? When we talk about the derivative, what are we really saying? So the derivative at a point, let's say at a point A, at this point A on the x-axis, where does it hit the function? The derivative is essentially the slope of a tangent line. This is really important to understand. So at this point A, our function touches right here. Let me do it in red. Right now we see it. It's very, hopefully this is visible on the camera. Okay. And the tangent line is this red line here that passes through that red point. And it hits the function only at one spot, right here at the red dot. Okay? And what's important to understand is that notice that when the function is increasing, the slope of the tangent line is positive, it's going up. Okay? If we were to take the slope of the tangent line at this point, what do we have? We have a line that is going downwards. So notice that when the function is decreasing, the slope of the tangent line is going down. And when the function is increasing, the black function is increasing here, our red line, the slope of the red line is going up. And that's our tangent line. And this is super important because it helps us identify important parts, such as the peak over here. What do we know about the peak over here? This is good for business students, especially if they're trying to maximize functions. At the peak, the tangent line is going to be exactly horizontal. And what do we know about the slope when it's horizontal? The slope is exactly 0. There is no slope. So the slope here is 0. So let's say the slope here is 0. So what we're really finding is when the derivative is equal to 0. The derivative of the function x is equal to 0. This is what you're trying to find. And this is going to allow us to find peaks, maximum or minimum, or we have something else called a saddle point, which we'll learn about later on in the course. Okay? But what's important to understand is that the derivative is the slope of a tangent line at a given point. Okay? And the slope is how much it goes up or down. If we understand that, and the tangent line is also a line that hits the function only at one point. Okay, at the point A. Okay, so that's very important. This is the intuition I want you guys to have when approaching a derivative problem. Okay, so let me perhaps keep that there, and let's consider the function f of x is equal to pi x squared. Okay, this is a quadratic function, so that's fine. So if we have the function f of x equals pi x squared, let's take the derivative of this. So to take the derivative, we need the limit so f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all that divided by h. Using the definition, I just rewrote it. And now let's plug in everything we know. We have to plug in now the function of x plus h. How do we do that? Let's do this on the side perhaps. F of x equals pi x squared, right? Let me put brackets just to emphasize this. Whatever's in the brackets over here, right here, was placed over here. So it was squared and it was multiplied by pi. Pi is just a number. Now, if we have f of x plus h, notice that whatever's in the bracket here just gets replaced in this bracket. So instead of writing x, we're going to write pi x plus h squared. Okay, this is how we do that. The x plus h is basically just placed into here, into the bracket. So the whatever's in the bracket here was placed here, we squared it and then multiplied it by pi, essentially. So this is f of x plus h. So now we go back to our derivative here. Keep writing equals, rewrite the limit in the front, important. Limit as h approaches 0, don't forget that guy. F of x plus h we just found, it's pi x plus h squared minus f of x. F of x is the function that we started with, pi x squared. Let's do this. And all that divided by h. Okay. Let me just erase over here because the board is small. Oh, this eraser is not good. Just to give myself a bit more room, I'm going to come back up here and continue. So we have the limit as h approaches 0. What we're going to do next is expand the squared. Okay? Whenever you have a constant in front, be very careful. Don't use the constant first. Ignore him for now. Just focus on the exponent 2. And here we're not allowed to just distribute the 2 in the exponents. This is a mistake that a lot of students make, that math teachers hate. The plus stops us from doing that. Okay? So what we have to do here is just take the x plus h and multiply it by itself. Okay, that's what squared means. So I'm going to just come back up here and continue. So I'm going to write equals the limit as h approaches 0. This is a bit computational over here. The pi stays, I rewrote the pi. But instead of writing x plus h, I'm just going to write x plus h squared. I'm going to write x plus h times x plus h. Okay? That's the squared part. And then minus pi x squared. Minus pi x squared. And remember, all that divided by h. Okay? Now what you have to do is just expand the top part. Okay? So we get equals the limit as h approaches 0. The pi is a constant. We could just leave him for now. It doesn't bother us. Always start off by foiling and then worry about the constant. So here we're just going to distribute or foil the x times x times h times x, h times h. This you guys saw a lot in math 206 and 201. You guys see it a lot. So x times x is x squared, x times h is hx, plus h times x, hx again. The order doesn't matter. 2 times 3 is the same as 3 times 2, so it doesn't matter which way you put it. And finally, h times h is h squared. And then remember, it's minus pi x squared. Okay? All that divided by h. Everything's divided by h. Okay, great. So let's simplify the bracket. We have the limit as h approaches 0. It's important to keep rewriting this in the front of pi. And let's just deal with the bracket first. We have x squared plus hx plus hx plus h squared. We have 2 hx's because hx plus hx, combining like terms, we get 2 hx. So we get x squared plus 2 hx. I'm really hoping the video could see this. It's not too small. 2hx plus h squared, all that in bracket, minus the pi x squared divided by h. Okay. So now that we distributed, we used FOIL method. Now we're ready to distribute the pi. Okay. So we have the limit as h approaches 0 of pi x squared, because I'm multiplying the pi in. We get pi x squared plus 2 pi hx plus pi times h squared is pi h squared minus pi x squared. So this is very computational. It's important when you're doing math problems not just to watch someone do it, to actually like pause the video and do it yourself and then see if your answers match. Okay, so now on the top part over here, what we have is we have 2 terms that are the same opposite sign. We have pi x squared and we have negative pi x squared. Nice. Those guys cancel. Cancel them out. Okay? And we're left with the limit as h approaches 0 of 2 pi hx plus pi h squared. All that over h. Okay? The next step over here, we're doing pretty well. But notice if you plug in the limit as h approaches 0, you plug in h as 0, you replace h as 0, you're going to get 0 over 0, and this is an issue. So that means you basically just have to keep simplifying. Okay, so the trick here that you would have to do is factor. You're gonna have to factor out a h from the numerator. Okay, so what we get is the limit as h approaches 0 of, I'm gonna factor out a h from the numerator, so we have 2 pi hx. Factor out the h, what are we left with? A 2 pi x. And on the second term we have pi h squared. Factor out a h, we're left with pi h. Okay, on the top, and there's still that h on the bottom. Now we got to the point where it's nice. So notice the h that we factor out is going to cancel with the h that was sitting on the bottom. Okay, so we could cancel those guys. The h is canceled. What are we left with? Sorry, there's not enough room here. I'm going to have to erase and continue over here. So I'm just going to erase this part here. Yeah, this board is very small, unfortunately. Okay, so let's continue over here. So now from this, I'm just gonna, sorry for all the arrows, I'm gonna continue back up here. Okay, so what we have written now is we still have the limit as h goes to 0. And then on top, what are we left with? The 2 pi x, as well as the pi times x. Oh, sorry, the pi times h, not x. We're left with, yeah, pi times h. And what's nice about this is now we're ready to take the limit. So take the limit as h approaches 0. So basically replace your h with the 0. What do we get? So now I don't have to write the limit anymore because we're applying it. The 2 pi x in the front stays, plus we get pi times h, which is 0. So replace the h with a 0. Okay, and pi times 0 is 0. What are we left with? 2 pi x. Very nice. Okay, so we started with the function pi x squared, and we finished with the derivative of it, f prime of x, which we solved using the limit definition to get 2 pi x. This is great, and what this also shows, this is a little bonus on the side, I'm just going to erase this. Notice, if we take the function that I started with, this should look familiar from high school. Ah, this eraser's not good. Yeah, so the function that we started with was pi x squared. If I replace my x with r's, this formula should look familiar. Pi r squared. This, if you guys remember, is the equation for the area of a circle. Everything inside the circle, it's pi r squared. And when we took the derivative of it, we ended up with 2 pi, replace x with r. And if you guys notice this, 2 pi r, this is actually the circumference of the circle, which is great because from the derivative, when we took the derivative of the equation for the area of the circle, we ended up obtaining the circumference of the circle, which is all around. So this is a nice little example to see how things are related. But let's get to the fun stuff. Let's get to the equation of a tangent line. So this is just a little bonus.